Okay, so quite a few people have been having trouble with the reflexive property. So the reflexive property is something that can be a little confusing if you overthink it. So try not to overthink it. So I'm going to start off by giving some examples. Hopefully these examples will make sense and you won't have any trouble with them. So basically, the reflexive property is used whenever there are parts that are shared. Now, when I say you can use it with angles, you can use it with sides. So like if we have two triangles, if they share a side, then you can use the reflexive property on that. So when I talk about sharing a side, I mean sharing it exactly the way it is. So for instance, let's say we start off with a parallelogram. Okay, no triangles there. But I want to turn that into triangle. So I draw a line down the middle. Now we can look at this as one big parallelogram, or we have two different triangles in here, right? Okay. Now, if you look at this distance from here to here, okay, that's the shared side. Now notice that this triangle, it goes exactly from A to C, and this triangle goes from A to C too. There's no overlap. So let me show you something that's a little different. Now let's say, for instance, instead, we have something like this. Okay, so in this case, this triangle and this triangle, they share part of the side, right? But part of the side is not being counted. So we're not going to use the reflexive property here. So we're not going to use it here. Here's where you can use it. And the main thing you really need to understand is, well, I'm going to show you I'll just demonstrate with measurement. Okay. So what happens when you measure this side? Well, normally when you do it with a ruler, you measure from one side or the other. So let me just ask you. I'm going to go ahead and measure from the top side of the right here. So from this triangle here, ABC. And so ABC, it looks like it goes, I'm going to measure with centimeters, and it goes 9.58. 9.8 centimeters. Okay, so it doesn't matter what side I measured from. Let's go to the other side and measure there. And we get, I'm going to use same measurements, centimeters. So 9, 5, 6, 7, 8. There it is, 9.8 centimeters. Okay, does that happen every time? Well, let's try something. Let's say we have I don't know, I just made up a different shape, a pentagon, right? Okay, and let's say we want to measure, I'm going to go draw a line. I'll do it from here to here. Okay, so we have a triangle on one side, and we have a quadrilateral of some sort over here. It looks like it's kind of like a trapezoid. So I'm going to measure from the triangle side, and let's measure with inches. So that's almost exactly 3 inches. So 3 inches. Okay, so if I measure from the other side, how long is that going to be? 3 inches. Okay, so hopefully, if you didn't know it before, hopefully you see that no matter what it looks like, if I draw a line or line segment, if I measure from one end to the other end, this one is about 2 5/16. That's the length. If we go to the other side and measure it, it'll be the same length. In this case, 2 5/16. Now that's inches, right? If we measure that in centimeters, we'll get a different measurement on this side. It looks like about 5.8. But if we do the same measurement on centimeters on the other side, we should get 5.8. Okay, so no matter how you measure it, this is still going to be the same length on either side. Now that may or may not sound obvious to you, but that is called, we have to have a name for it, or we don't have to, but it makes it easier so that we know what we're talking about. We're going to call that the reflexive property, that something is equal to itself. Now, if we never used it, we wouldn't need a name, I suppose. But the way that it's going to be used in geometry is that when we're comparing two or more shapes that share the same size, you need to make sure you remember that one side is in both shapes. So, for instance, if we look at AB and CD, let's say, for instance, they're congruent. Okay, well, AB is only in this one triangle on the top right here. CD is only on this one. So we have two separate marks. And let's say, for instance, BC is the same length as AD. Well, we can mark it. So what we have now is one pair of sides here, one pair of sides here. So we have, if we're trying to show that the triangles are congruent, we have side, side. But we need side, 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 or side, angle, side, or angle, side, angle. We need three things. Two isn't enough. So we need something else. But you have to make sure you remember that this side, even though there's only one line segment, it's the side for two different triangles. So you get to count this one twice. So it's 9.8 on this side and 9.8 on this side. It's the same on both sides. So we can say for both triangles, it's the same. It's congruent to itself, and that is the reflexive property. So we can say AC is congruent to AC. So we know BA, that was the first one. BA is congruent to CD. BC is congruent to AD. Now notice the top one, the one we're using the reflexive property on, is the only one that has the same letters on both sides. So these are two different sides that are still congruent. These are two different sides that are congruent. But this is the same side we're using twice. It's like looking in a mirror, like a reflection, right? And when you look in the mirror, you see the same thing, except the other side, I guess. It's kind of reversed. So that's what the reflexive property is. I hope it helps.